we're looking at a piece of software called Stellarium. Okay, so we look up at the sky and face north, and there we go, everything is rotating anti-clockwise around Polaris. Now if we face south, then in the planisphere projection, which is very much like what you would actually see, as opposed to some of the other projections that you can commonly see, which don't reflect what you would actually see very closely. But in this projection, when we look south and we're standing in the UK, we see the stuff sort of drifting across the sky. It's not a rotation in our field of view we're looking here already here. It's a sort of flow of stars here from left to right. Okay, so what happens in this projection if I visit Australia or New Zealand? So we click down to New Zealand, and in New Zealand I'm now going to face, so at the moment I'm facing south. Okay, so in New Zealand facing south, what do we see? We see the stars rotating clockwise. And I'm facing south. And they're rotating clockwise around the pole there. Okay. So that matches up with what we would expect to see. A clockwise rotation as opposed to an anti-clockwise rotation, which you see in the Northern Hemisphere. And when I turn around and I look north, what do I see? I see the kind of flow of stars from one side of the sky to the other, going the opposite direction. So what's the point of what I've shown you? Well, it shows you that in the planisphere projection, there's only one axis of rotation going on. So the stars are only circulating around one point, and when you look in the other direction, they are not circulating around a point at all. Okay, so that is what we observe in both hemispheres, except that the direction is reversed. So we see things rotating around when we look north in England, and when we look south in New Zealand. So we're led to believe that that's because in New Zealand, so if you're in New Zealand, you think you're looking towards the South Pole, because South Pole doesn't exist in the flat Earth model. When you're looking south in New Zealand, you're looking to what us in Europe and say England, the UK, is north. So if you look south in New Zealand, you're really looking north from a UK person's perspective. And if you're looking north from a New Zealand perspective, you're looking south from a UK perspective. So if you look at the flat Earth map, you can see why that is. Because the north and south are opposing each other. They're 180 degrees apart. So it doesn't enter into anyone's minds to think about this in the globe model, because of course in the globe model they don't think they're looking at the same thing. They think they're on the bottom of the world. So what I've showed you explains how in a flat Earth model you would observe exactly the same phenomena as you see in the spherical world model. So I can go to Australia and see what I'm told I'm going to see, the rotation around what I'm told is the South Pole when I look south, and a kind of indistinct kind of flow of stars when I look north. And in the Northern Hemisphere I'm seeing what I should. So I see what I should when I'm in what I think is the appropriate hemisphere. But it's all a big hoax.
In an astrolabe, the Earth is represented in stereographic projection on a flat plate called the mater. The ecliptic circle and important stars are represented on another plate called the ret. Different planetary orbits could likewise be represented by different plates, and these would be seen projected onto the Earth plate when one looks down on the instrument. The Bhagavatam similarly presents the orbits of the Sun, the Moon, and important stars on a series of planes parallel to Bhumandala. The orbits of the planets are placed on additional parallel planes. Here we see the Bhagavatam's model of the orbits of the Sun, Moon, and 28 important star constellations. These lie in 3 planes parallel to Bhumandala. The layout is comparable to that of an astrolabe. Seen from above, everything falls into place in projection in an astronomically realistic way.